Okay, in this video, we continue with differentiation of inverse trigonometric functions, and my first question here is y is equal to sine inverse of 1 minus x square by 1 plus x square. So what you need to see is if you need to check if there is any inverse trigonometric function formula like this. There is something similar to this, of course not with sine inverse. So what is that formula? Cos inverse of 1 minus x square by 1 plus x square is 2 tan inverse of x. This is something which we learn under inverse trigonometry chapter, in inverse trigonometric functions chapter. Cos inverse of 1 minus x square by 1 plus x square is 2 tan inverse of x. But unfortunately for us here, it's sine inverse. So is there any way I can change this sine inverse into cos inverse? Yes, we do have a formula. Sine inverse of x can be written as pi by 2 minus cos inverse of x. So sine inverse of x is pi by 2 minus cos inverse of x. So sine inverse of so much will be pi by 2 minus cos inverse of so much. So sine inverse of 1 minus x square by 1 plus x square will be pi by 2 minus cos inverse of so much, 1 minus x square by 1 plus x square. So sine inverse of x is pi by 2 minus cos inverse of the same x. Now this cos inverse of 1 minus x square by 1 plus x square, I can replace it with 2 tan inverse of x. So my question now reduces to pi by 2 minus, instead of this I have the formula 2 tan inverse of x. So I replace cos inverse of 1 minus x square by 1 plus x square by 2 tan inverse of x. So my y is this. So now I can differentiate. So dy by dx would be pi by 2 derivative is 0 minus 2 into tan inverse of x derivative is 1 by 1 plus x square. That is minus 2 by 1 plus x square is the derivative. So you have a question here, y is equal to cos inverse of 2x by 1 plus x square. There again, do we have a formula like this? No, there is something similar to this, but that is in sine inverse. Sine inverse of 2x by 1 plus x square is 2 tan inverse of x. So if this was sine inverse, that is sine inverse of 2x by 1 plus x square, I could have written it as 2 tan inverse of x. So that's when we come up with the same formula here. This cos inverse has to change to sine inverse. So I can write cos inverse of x is equal to pi by 2 minus cos inverse of x. Cos inverse of anything will be pi by 2 minus cos inverse, sine inverse of the same thing. So this cos inverse of 2x by 1 minus x square, I will rewrite as pi by 2 minus sine inverse of so much. And then I differentiate it. Okay, so that's exactly like the question which I did here. Next one, 115, y is equal to sine inverse of 2x into root of 1 minus x square. So in this question here, there is sine inverse outside, so the inside expression should reduce to something in sine. So what sine formula matches with it? So I have sine 2 theta is equal to 2 sine theta cos theta. I know that 2 sine theta cos theta would reduce to sine 2 theta. So if what I'm planning to do is choose x as sine theta. If I choose x as sine theta, this will be 2 sine theta into root of 1 minus sine square theta. So I'm going to make that substitution. I'll say let x be equal to sine theta. Therefore my question would reduce to y is equal to sine inverse of 2 times sine theta into root of 1 minus sine square theta. Now 1 minus sine square theta would be cos square theta. Root of that will be cos theta. So that's going to be sine inverse of 2 into sine theta cos theta. Now 2 sine theta cos theta according to this formula is going to be sine 2 theta. So I'll get it as sine inverse of sine 2 theta. Now sine inverse and sine will cancel, which will give me just 2 theta. And then I need to replace theta by its value. What is theta? Go back and see here. X is equal to sine theta, which means theta would be shifting sine to the other side. So theta would be sine inverse of x. So this is going to be 2 times sine inverse of x. And that's my question now. So that's y is equal to 2 sine inverse of x. Therefore dy by dx would be 2 times Derivative of sine inverse of x is 1 by root of 1 minus x square. So dy by dx is actually 2 by root of 1 minus x square. You have a question for homework. Y is equal to sec inverse of 1 by 2x square minus 1. So the formula which we would use is cos 2 theta. Cos 2 theta is 2 cos square theta minus 1. See, all this, if it has to strike you, you've got to be so very familiar with all the trigonometric identities. So the moment you see an expression that way, it would strike you. So 2x square minus 1, 2 cos square theta minus 1 is cos 2 theta. So I will say let x be equal to cos theta. So this is going to be 2 cos square theta minus 1, which is cos 2 theta. But 1 by cos 2 theta will become sec 2 theta. Then sec inverse and sec will get cancelled. And you should be able to complete that question. Y is equal to tan inverse of root of 1 plus x square plus x. Look at this question. It's going to be slightly different from all the previous questions, because in all the other questions we always had a direct trigonometric formula available. Now we don't have any formula for tan inverse in this pattern. Now if you don't have any direct trigonometric formula available, then we have a set of rules. So I'm going to discuss those rules in this section. When there is no direct trigonometric formula available, so this, what I'm going to say here, is applicable only when there is no direct trigonometric formula available. And if it involves a square plus x square, then put x is equal to a tan theta. So if your question involves a square plus x square, make x is equal to a tan theta. Now what's the logic in it? If I have a square plus x square, I would make it as a square plus x is a tan theta. So a square plus a square tan square theta. Then there is a square common factor. So I'll get a square into 1 plus tan square theta, which is sec square theta. So that's the logic. So, but if you see this question, here it is 1 plus x square. So I need to write that special case, which means a is 1. So if a is 1, x is equal to 1 tan theta. So I'm going to write that separately. So if I have 1 plus x square, then substitute x is equal to 1 tan theta, or rather tan theta. 1 plus x square, substitute x is equal to tan theta. So that's the basic result. If there is no direct trigonometric formula available, and if it involves 1 plus x square, substitute x is equal to tan theta. Second case is, if it involves a square minus x square, substitute x is equal to a tan theta. For example, if it is 25 minus x square, 5 square minus x square, put x is equal to 5 sine theta. In particular, if it is 1 minus x square, then substitute x is equal to 1 sine theta, which is sine theta. So 1 minus x square, x is equal to sine theta. The next one is, if there is a question where it involves both 1 plus x square and 1 minus x square, then I should replace x square by cos theta. So let's just go through this one more time. So when do we think about it? When there is no direct trigonometric formula available, and if it involves 1 plus x square, you substitute x is equal to tan theta. If it involves 1 minus x square, then substitute x is equal to sine theta. If it involves both 1 plus x square and 1 minus x square in a question, then you should substitute x square is equal to cos theta. Now for example, if instead of 1 plus x square, if it is 1 plus root x and 1 minus root x, I will say root x is equal to cos theta. If it is 1 plus x cubed and 1 minus x cubed, I'll say x cubed is equal to cos theta. If it is just 1 plus x and 1 minus x, I'll say x is equal to cos theta. Basically what I want is, once I make the substitution, it should look like 1 plus cos theta and 1 minus cos theta. Because both 1 plus cos theta and 1 minus cos theta have got results. These results, 1 plus cos theta is 2 cos square theta by 2, and 1 minus cos theta is 2 sine square theta by 2. So 3 basic results. If a question involves 1 plus x square, substitute x is equal to tan theta. If it involves 1 minus x square, then substitute x is equal to sin theta. If it involves both 1 plus x square and 1 minus x square, substitute x square is equal to cos theta. Remember, this is x square. Then only it will become like 1 plus cos theta, like 1 plus cos theta, which has got a result, and 1 minus cos theta, which has got a result. So one more time. When there is no direct trigonometric formula available, and if it involves 1 plus x square, substitute x is equal to tan theta. 1 minus x square, substitute x is equal to sin theta. 1 plus x square and 1 minus x square is equal to cos theta. But instead of x square, it could be anything else, like 1 plus root x and 1 minus root x. I'll say let root x be equal to cos theta. If it is 1 plus x cubed and 1 minus x cubed, I would say x cubed is equal to cos theta. So these are the basic rules there. One more time before we go to the question. If a question involves 1 plus x square, make x is equal to tan theta. If it involves 1 minus x square, put x is equal to sin theta. If it involves both 1 plus x square and 1 minus x square, then make x square is equal to cos theta. So we're going to go back and do this question now. So I'll write the question one more time. Y is equal to tan inverse of 1 plus root of 1 plus x square plus x. There is no direct trigonometric formula available. So that means I will be using one of the rules which I discussed earlier. This question involves 1 plus x square. So the rule which we learned tells me to make a substitution x is equal to tan theta. So wherever x comes, I'm going to make it as tan theta. So when I make that substitution, my question becomes tan inverse of root of 1 plus tan square theta plus tan theta. What is 1 plus tan square theta? 1 plus tan square theta is sec square theta. So tan inverse of root of 1 plus tan square theta becomes sec square theta plus tan theta. Now what is root of sec square theta? Root of sec square theta will be sec theta. So you get tan inverse of sec theta plus tan theta. Sec theta can be written as 1 by cos theta, and tan theta can be written as sin theta by cos theta. So your question is going to be tan inverse of 1 by cos theta plus sin theta by cos theta. We put them as fractions. Sec theta is 1 by cos theta and tan theta is sin theta by cos theta. Now I take the LCM. When I take LCM, I'll get tan inverse of 1 plus sin theta by cos theta. Common denominator is cos theta, so just add 1 and sin theta. Now when you reach this stage, you need to do some kind of simplification, but we are stuck because there is no result on 1 plus sin theta. Absolutely no result on 1 plus sin theta. But if it was 1 plus cos theta, you have a half angle result. So what I'm going to do is I want to change this sin theta into cos. So let me change that. So that's going to be tan inverse of 1 plus, instead of sin theta, I'll write cos 90 minus theta. Sin theta can be written as cos of 90 minus theta. Sin theta is cos of pi by 2 minus theta. But the problem is, if I change the angle in the numerator, I should also change the angle in the denominator. So I am forced to change cos theta, which is in the denominator there. So cos theta will be written as then sine of 90 minus theta. So I'm going to change denominator, sine of 90 minus theta, pi by 2 minus theta. Cos theta is written as sine of pi by 2 minus theta. Now if you think about it, this is 1 plus cos theta, which has a half angle result, 2 cos square theta by 2, half of the angle, 2 cos square theta by 2. And denominator is like sine theta, which has a half angle result as well, 2 sine theta by 2 cos theta by 2. So we're going to apply those formulae in the numerator and denominator. So 1 plus cos theta is 2 cos square theta by 2, half of this angle, half of pi by 2 minus theta. Half of pi by 2 is pi by 4 minus half of theta is theta by 2. So 1 plus cos theta is 2 cos square theta by 2. Theta by 2, half of the angle theta. Half of pi by 2 is pi by 4 minus half of theta is theta by 2. divided by the sine theta. Sine theta is going to be 2 sine theta by 2 cos theta by 2. So 2 sine theta by 2, half of this angle, pi by 4 minus theta by 2, the cos theta by 2, pi by 4 minus theta by 2. Just for you to understand it better, I am writing the half angle formula here. So 1 plus cos theta is 2 cos square theta by 2, and sine theta is 2 sine theta by 2 cos theta by 2. These are the two formulae applied. 1 plus cos theta became 2 cos square theta by 2, half of that angle, divided by sine theta, according to this formula, became 2 sine theta by 2 cos theta by 2, half of that angle. You can see that 2 and 2 will get cancelled. Cos from the numerator and 1 cos theta from the denominator, and one of the cos terms from the numerator will get cancelled. So what I have is tan inverse of 2 and 2 is gone, cos and 1 cos is gone, so I have just a cos pi by 4 minus theta by 2 by sine pi by 4 minus theta by 2. So that makes it cot pi by 4 minus theta by 2. But this is what I was hoping for, was that tan inverse and that tan would come, so tan inverse and tan would get cancelled. Unfortunately, it didn't happen, because what was left here after cancelling one cos was cos by sine became cot pi by 4 minus theta by 2. So tan inverse and cot won't cancel, so I want to change tan inverse into cot inverse. So I'm going to copy that step one more time. Tan inverse of cot of pi by 4 minus theta by 2. This tan inverse, I'm going to change. Tan inverse of x is pi by 2 minus cot inverse of x. So I'll write this tan inverse of this whole thing will be pi by 2 minus cot inverse of the whole thing. So tan inverse of this whole thing is my x. Tan inverse of x will be pi by 2 minus cot inverse of x. So pi by 2 minus cot inverse of the whole thing, cot of pi by 4 minus theta by 2. Now you can see cot inverse and cot will get cancelled. So I have pi by 2 minus pi by 4 minus theta by 2. Open the bracket with the minus sign. Pi by 2 minus pi by 4 will be pi by 4, and minus into minus is plus theta by 2. So you'll get pi by 4 plus theta by 2, which is equal to pi by 4 plus half theta. What is theta? Our substitution was x is equal to tan theta, which means theta is tan inverse of x. Replace theta by its value, and now I differentiate. Therefore dy by dx would be pi by 4 will go 0. Half is coefficient which will stay there outside, and derivative of tan inverse of x is 1 by 1 plus x square, which is your answer. Of course, I multiplied the two denominators together. So 1 into 1 is 1 divided by 2 times 1 plus x square, and this is the question for you. Y is equal to cot inverse of root of 1 plus x square plus x. So this is the same question, almost the same question. It has got a 1 plus x square, so put x is equal to tan theta. I'm going to look at another question. Y is equal to tan inverse of root of 1 plus x square minus 1 by x. Again, there is no direct trigonometric formula available for tan inverse in this pattern, but it involves 1 plus x square. When there is no direct trigonometric formula available, and if it involves 1 plus x square, put x is equal to tan theta. We say let x be equal to tan theta. So your question becomes y is equal to tan inverse of root of 1 plus x square, tan square theta, minus 1 by x. X is tan theta. What is 1 plus tan square theta? That is sec square theta. Root of that will be sec theta. So I'm going to get tan inverse of sec theta minus 1 by tan theta. Once again, 1 plus tan square theta is sec square theta. Root of sec square theta is sec theta minus 1 by tan theta. I'm going to change everything into sine and cos. Sec theta will be 1 by cos theta, and tan theta will be sine theta by cos theta. So tan inverse of 1 by cos theta minus 1 by sine theta by cos theta. Take LCM. So 1 minus cos theta by cos theta, sine theta by cos theta. The denominator cos theta will cancel. So I have 1 minus cos theta by sine theta. One more time. When I take LCM, it is 1 minus cos theta by sine cos theta. divided by sine theta by cos theta. By cos theta, from both numerator and denominator cancels, and this is what I get. Now both 1 minus cos theta and sine theta have got half angle formulae. So I'm going to apply those formulae. 1 minus cos theta is 2 sine square theta by 2. 1 plus cos theta in the previous question we wrote as 2 cos square theta by 2. 1 minus cos theta is 2 sine square theta by 2. So if it is minus, it becomes 2 sine square theta by 2. If it is 1 plus cos theta, it would be 2 cos square theta by 2. So I wrote 1 minus cos theta as 2 sine square theta by 2 divided by sine theta is 2 sine theta by 2 cos theta by 2. 2 and 2 will cancel. 1 sine theta and sine theta will cancel. So what I have is sine theta by 2 by cos theta by 2, which will be tan theta by 2. Sine theta by 2 by cos theta by 2 is what I have after cancelling the like terms. And then sine by cos makes it tan. So tan inverse of tan theta by 2. Tan inverse and tan will cancel. So I have just theta by 2. And what is theta? If tan theta is x, theta will be tan inverse of x. So half tan inverse of x. And now I can easily differentiate. Therefore dy by dx will be half into tan inverse of x is 1 by 1 plus x square. So 1 into 1 is 1 divided by 2 times 1 plus x square. We'll continue in the